Lesson 4-1, Graphing Quadratic Functions. By the time we're done with this section, we should be able to graph quadratic functions, find and interpret the maximum and minimum values of a quadratic function, and state domain and range. So to start with, we're going to talk about the different forms that our quadratic function can be in. So the first form we should be familiar with is called the vertex form. So in our function notation, we would have f of x equals a times a quantity of x minus h squared plus k. And we call it vertex form because we can easily identify the vertex when it's in this form. So remember, the vertex is the opposite of h and then our k value. Now we also have standard form where we would have ax squared plus bx plus c. So this is the simplified version of the vertex form. And we're going to talk in a minute about how those two are related to each other. So, but when we're looking at standard form, this first term is our quadratic term. And then the second one is our linear term. And then the very last one is just a number, so that is our constant. So now remember, when I'm saying the word term, that's talking about a group that's separated by either a plus or a minus. So each one of these are terms. This one's the quadratic term because it has the x squared. This one's our linear term because it has just the x value. And then since c is just a number, that's our constant. Now our quadratic makes our u shape, which is also called our parabola. And again, remember, at the very bottom of our u is our vertex. So now we're going to kind of talk about how our two different forms are related. So remember, when we're graphing, we always start with the vertex, but we don't have an h and k in our standard form. So we're going to go through and simplify vertex form to show how we would find the vertex when it's in standard form. So when we are simplifying vertex form, whenever we have a power, that's telling us how many groups there are. So this really means the same thing as a times x minus h, and then another x minus h group plus k. So we're just going to simplify it as far as we can go. So we're going to start with our multiplication, and I'm going to start by multiplying our two parentheses together. So we're going to use FOIL to do that. Okay, so that means a is still going to be on the outside, and I'm going to put a parenthesis there because we will still need to multiply when we're done. So we take x times x, so that's x squared. X times h, a negative h, will be a negative hx. And I'm writing x second because that's our variable and h is just a number. And then we have negative h times x, so another negative hx. And then negative h times negative h will be positive h squared. And then we're closing in parentheses, and then we still have the plus k. So now I'm going to combine like terms on the inside. So we have two hx's, and then after we combine, we have to distribute a to every single term. Okay, so this will be ax squared minus 2ahx plus ah squared plus k. And then we don't have any more like terms, so now we can kind of start talking about how the two are related. So remember, standard form is ax squared plus bx plus c. So when I'm looking at this, so if I start with my first set right here, these would have to be the same when we're looking at standard form. So since we have the a squared, we don't really care about that. We're just looking at the variable in front. So for this, we know that a has to be the same as a no matter what form it's in. So now if we look at the second set where we have the x, okay, so that's going to be this set right here. Okay. So again, since we have the x there, we don't really care about that part. We care about all of the other variables. So that means that negative 2ah has to be equal to b. So if we're looking at this, it has an h in it. So if I solve this for h, that's going to help me figure out our vertex. So that means that I would have to divide both sides by negative 2a. Okay, so it cancels out here. So h equals, and then we would simplify the negative up to the top part of our fraction. So negative b divided by 2 times a. And then our last part, the constant, so that's our c, is going to be all of this. Okay. So that means that c equals our ah² plus k. So if we really wanted to, we could solve this for k. So I would subtract our a and h squared to the other side. So we would have k equals, and then a negative a h squared plus c. But that's not really going to help us because we would still have to know what h is. So when we're looking at this, we really care about this part, so the a's, and then our h. So those two pieces of information we're going to use to help us identify the vertex when it's in standard form. So to find the vertex, our x value, which again is the same idea as our h, okay, so this really means h, is always going to be the opposite of our b term divided by 2 times a. And then to find y, so again this is the same idea as our k, we're going to take whatever number we get for this one and we're going to substitute it into our standard form equation and then evaluate. So we're going to be doing f of and then h, okay, which is the same idea as saying f of negative b over 2 times a. So that's what we're going to use to find the vertex when it's in standard form. And then from there, we should be able to graph. So we still need at least 3 points. We still start with the vertex. And then we want to pick a point, an x value on each side of it. And then we would use a table to help us find our other points.